Our next topic is spatial filtering. We are going to start with linear spatial filtering. The concept of linear filtering has its roots in the use of Fourier transform for signal processing in the frequency domain. The toolbox implements linear spatial filtering using function imfilter, which has the following syntax. In this, f is the input image, w is the filter mask, g is the filtered result. The filtering mode is specified as CORR for correlation, this is by default, or as CONV for convolution. The boundary options deal with the border padding issue, with the size of the border being determined by the size of the filter. The size options are either same or full. The most common syntax for imfilter is shown below. This syntax is used when implementing standard linear spatial filters in the toolbox. These filters are pre-rotated by 180 degree, so you can use the correlation default in imfilter. If the filter is symmetric about its center, then both options produce the same result. When working with filters that are neither pre-rotated nor symmetric and you wish to perform convolution, then there are two options. One is to use the syntax g equals to imfilter f, w, conv, replicate. The other approach is to use function rot90 w, 2 to rotate wy 180 degree and then use imfilter f, w, replicate. Options for function imfilter. So here I have written the options for imfilter for filtering mode, for boundary options, and for size options. You can go through these three tables by yourself by pausing the videos. Next is nonlinear spatial filtering. Nonlinear spatial filtering is based on neighborhood operations also, and the mechanics of sliding the center point of m cross n filter through an image are the same. However, whereas linear spatial filtering is based on computing the sum of products, nonlinear spatial filtering is based, as the name implies, on nonlinear operations involving the pixels in the neighborhood encompassed by the filter. Two functions are used to perform nonlinear filtering, that is mfilter and callFilt. Function callFilt organizes the data in the form of columns and is faster than nlfilter. The callFilt function has syntax as shown below, where m and n are the dimensions of the filter region. Sliding indicates that the process is one of sliding the m cross n region from pixel to pixel in the input image f, and fun is the function handle. The function pad array is used for padding the input image explicitly, whose syntax is shown here. In this, f is the input image, fp is the padded image, rc gives the number of rows and columns by which to pad f, and method and direction are explained in the table. So you can pause your video here and go through method and direction by yourself. Next is linear spatial filters. The toolbox supports a number of predefined 2D linear spatial filters obtained by function fspecial, which generates a filter mask w, whose syntax is shown here. In this, type specifies the filter type and parameters further define the specified filter. The spatial filters that fspecial can generate are summarized in the table, including applicable parameters for each filter. You can go through these by yourself by pausing the video here. Next is nonlinear spatial filters. Function oddFilt2 computes order static filters These are nonlinear spatial filters whose response is based on ordering the pixels contained in an image neighborhood and then replacing the value of the center pixel in the neighborhood with the value determined by the ranking result. The syntax for function oddFilt2 is shown here. This function creates the output image G by replacing each element of F by the ordered element in the sorted set of neighbors specified by the non-zero elements in domain. The function MATLAB is used for median filtering, having syntax shown below. The tuple Mn defines a neighborhood of size m cross n over which the median is computed, and padopt specifies one of three possible border padding options, that is zeros, which is by default, symmetric, in which f is extended symmetrically by mirror reflecting it across its border, and indexed, in which f is padded with ones if it is of class double and with zeros otherwise. Median filtering is a useful tool for reducing salt and pepper noise in an image. So this is all in this lecture. In our next lecture, we will discuss about frequency domain filtering. Thanks.